Hello everyone, Professor Clark back for our next math. Continuing on with our quantity takeoff for our masonry building. And last time we got up to our number of brick. Just before that we did our number of block, 2,388 block, 11,965 brick. Okay, and then after that we can see that we have our sand and our mortar for items number 13 and items number 14. Okay, our sand and our mortar are basically one item. Okay, our sand and our masonry cement are basically one item. Okay, we'll do the math and determine both of them together. Okay, but obviously we understood when we talked about mortar in the lab, and we did get to this down in the lab, that our mortar is made up of three components: sand, masonry cement, and water. Okay, we've already talked about the fact that we don't include the water. Okay, it is possible that I would have to include quantity of water. I'm gonna have to bring a water truck to a job site or bring barrels of water to a job site if I don't have access to water on the site. But in making the assumption that we have access to water, we are going to focus on determining our quantity of sand, which is given to us in cubic yards or ordered in cubic yards, and our quantity of masonry cement, which is given to us in bags. Okay, bags of masonry cement. There's other ways to do this. There's things like spec mix, where it already comes pre-mixed and we just add water. Okay, but that's how we're going to look at it. We're going to look at it as if we order our sand separately and our masonry cement separately. Okay, again, we've already talked about this. To use the term mortar right here is a misnomer. Most people in the industry call it a bag of mortar. Technically, it's not a bag of mortar. It's a bag of masonry cement. And when it's mixed with sand and water, it becomes a mortar. Okay, so again, not a big deal. Just have to understand that we're talking about our masonry cement and our sand separately. Okay, and when I mix all of those together, I make mortar. And what else happens when I mix all of those together? Okay, I create what? A volume of material. Okay, so you can see, you will see that we're going to determine this in cubic feet. Okay, so up till now we've been determining everything by area, using area. Now we're going to determine this information using volume. Okay, this is a volume. Technically, this is a volume 2. I could pour that material into a bucket. Okay, but our units are going to be in bags. All right, so again, we have to refer to the information that's given to us. Okay, and this time using your practice copy, and when you get to your assignment, using your actual copy. But for now, using our practice copy, everybody go to the last page of their practice copy. Okay, and we've already seen these charts. Okay, we've got our two charts. Okay, my bottom chart was my brick chart, telling me my different sizes of my brick according to what type of brick I have. Okay, we talked about nominal dimensioning versus actual dimensioning. We use our nominal dimensioning instead of our actual dimensioning for our quantity takeoff. Okay, but again, we've already covered this spreadsheet down here, this chart down here. That's giving us the information that we talked about with our brick. If we look at our top chart now, okay, we can see that that is mortar quantities. Okay, right here at the top tells us that it's in mortar quantities. Okay, and it tells us that our units are cubic feet. Okay, I can see cubic feet of mortar quantities. Again, a volume. Okay, so we start out by understanding that now we are dealing with volume as opposed to area. Okay, looking further down onto this chart, we see some additional information. Okay, first over here on the left-hand side of the chart, okay, we can see the different dimensions of brick, okay, that correlate to these different dimensions. Okay, so I can see that this first brick right here at the top has these dimensions, and that's the same dimensions that I have on the first item on this chart. Okay, so these dimensions correlate directly to the different type of brick we have. Okay, so according to what type of brick we have, we'll follow along and determine this information in a minute. Okay, and then also we can see down here that we have what? We have standard block. Okay, again, we can see that we've got two different widths there, but this number doesn't change. That's because I have a standard size block, 16 inches long by 8 inches tall. Doesn't matter how wide it is. If we remember laying block, I laid block on both beds and on my ears. Okay, doesn't matter how long or how wide it is. I'm still going to use the same cubic footage of mortar, okay, for any block. Okay, the width doesn't matter once again. Okay, all we're concerned with is that it's a standard size block, 16 by 8. And then finally we see right here that I have a 25% waste factor. Okay, that's another reason that this number doesn't change, because we've got a very high waste factor. Even if I do use slightly more mortar for a wider block than a smaller block, it's going to be compensated in the fact that we do that 25% down there. Okay, and we'll get to that. All right, so next, looking at this right here, we can see a bunch of numbers concerning these numbers right here. And what are those numbers? Okay, first off, we go up to the top of the chart here and we see different size joints. Okay, we see a 3/8 joint or a 1/2 inch joint. Okay, so we have 3/8 joint, 1/2 inch joint, 3/8 joint, 1/2 inch joint. Okay, we said that our standard size joint is a 3/8, so we're going to use a 3/8. We could use a 1/2 inch, but we're not going to, because a standard size joint most of the time in most spec books is 3/8. So that means we're going to use this column right here, and we're going to use this column right here. Okay, so the first column and the third column right there. Those are the two numbers we're going to use. Okay, and then we're going to know that by right here. Okay, up at the top. Okay, for this one right here, it says per 100 square feet. Okay, and I can see that for my block, I don't have any other choice. Okay, I have to use this column right here because it's the only column that I have a number in for my block. Okay, so per 100 square feet at a 3/8 joint, I'm using 6.0 cubic feet of mortar. So what is that telling me? That's telling me for every 100 square foot of block, no matter what size the block is, for every 100 square foot of block laid, I'm going to have 6.0 cubic feet of mortar, mixed mortar, to lay that block. Okay, that's what this chart is telling me. So again, we're correlating our area to a volume. Okay, so again, for every 100 square foot area of block, I will require 6.0 cubic feet of mortar. Okay, so depending on how many sections of 100 square feet I have, we already have our area. Okay, I can now divide that number by 100, and that'll tell me how many chunks of 100 square feet I have. And then I can apply that 6.0 cubic feet of mortar to determine my total mortar quantity. Okay, well, with my brick, I can see that I can use either. I can use per 100 square foot, or I can use per 1,000 brick. Okay, so either would be correct, but I'm going to make you use per 1,000 brick. Okay, so depending on what brick we use, okay, and again, that's going to be right here. I'm going to correlate this to this. Okay, and whatever brick I use is going to come over here, and in my 3/8 inch joint column, it's going to tell me the cubic footage of mortar that I need for 1,000 of those brick. So if I'm using a standard modular, I would follow this all the way across, because that's my first one on the chart here, first one on the chart here. And if I were using a standard modular, excuse me, I'd have 8.1 cubic feet of mortar. Okay, so again, this chart tells us the cubic footage of mortar correlated to 100 square foot of block and 1,000 of my brick. Okay, so hopefully everybody understands how to read that chart now. Okay, so now we can walk through and we can determine volume of mortar quantities for each of our masonry materials, our block and our brick. Okay, all right, so going to our board, okay, we will determine our mortar for our block. Okay, again, we're not at our final item yet that we're going to place into our list. Okay, first we have to determine the cubic footage of mortar for my block and my brick. Okay, all right, so we know that we have a certain amount of square footage. Okay, so my area, okay, my square footage, okay, sorry, let me explain that better. Okay, 100 square feet equals a square. Okay, another term, okay, another unit. Okay? If any of you have ever done any roofing, we order our roofing material by the square. That means 10 by 10 or 100 square feet. Okay, so it could be 100 by 1, whatever. 100 square feet equals a square. Okay, so a square of area, okay, 1 square of area, 100 square foot section, okay, again, is going to allow me to lay 6.0 cubic, or I need 6.0 cubic foot of mortar to lay that 100 square foot section. All right, so that is a square. So my square total equals my net area exterior plus my net area interior of my block, remember we separated them, divided by 100. Okay? So in order to figure out how many chunks of 100 square foot I have, or in order to figure out how many square I have, okay, I need to add my two net area together and then divide them by 100. Okay? So again, we've already determined those numbers. So for my exterior, I have 2,104.48 square feet plus, for my interior area, I had 395.75 square feet. Okay, and then all of that will be divided by 100. Okay, so or we could say 100 foot square feet per square. Okay, we know our square feet will cancel. Okay, everybody go ahead and do that math on your calculator, and I will get a total of 25.0 square. Okay, so for my block, I have 25.0 square. Okay, or 25 chunks of 100 square foot. All right, so now in order to determine how many cubic feet of mortar I need for my block, I will say 25 square times 6.0 cubic feet of mortar per square, or per 100 square feet. Okay, hopefully everybody understands that. My square are going to cancel, and I am going to get 150 cubic feet of mortar for my block. Okay, all right, so again, for my block, I added up my two areas, I divided by 100, knowing that it takes 6.0 cubic feet of mortar for every 100 square foot of block, or every square. And so now I know that I have for my block equals 150 cubic feet, okay, of mixed mortar. Okay, again, as if it were already mixed. My sand and my masonry cement and my water were all mixed together. All right, next, our brick. Mortar, mixed mortar for our brick. Okay? All right. For my brick, again, I told you that we have to use our chart. Okay? And what brick did we have? We have an engineered brick, which is the second one on my chart right here. Engineered brick. I follow that across. See my dimensions, which is 4 by 3 1/5 by 8. I know it's my second line up here. 4 by 3 1/5 by 8. I follow it across to my 3/8" mortar joint, and I see 8.6. Okay, what is that telling me? That for every 1,000 engineered brick I lay, it takes me 8.6 cubic feet of mortar to lay that brick. Okay, just like for every 100 square foot of block I lay, it takes me 6.0 cubic foot of mortar to lay that block. For every 1,000 engineered brick I lay, it takes me 8.6 cubic feet of mortar to lay my brick. All right, everybody understands that chart now. Okay, so the first thing we have to do is we have to put our brick into chunks of 1,000. So for every 1,000 brick, I know how much how many cubic feet of mortar I need. Okay, so by dividing our per 1,000 brick, we determined that we had 11,965 engineered brick, and I want to divide that by 1,000. Okay, so we just 1, 2, 3, move our decimal point over 3 times to the left, and we get 11.965 chunks of 1,000 brick. That's what that's telling us. Okay, so from there, I can fairly easily determine my quantity of mortar. Okay, so my brick mortar, or mortar for my brick, sorry. Mortar for my brick equals 11,000.965 chunks of 1,000 brick times 8.6 cubic feet of mortar per 1,000 brick. Okay, my 1,000 brick are going to cancel, and I'm going to get, okay, it looks like I did my math wrong on my notes. I used the wrong multiplier. So 11.965 times 8.6 equals 102.90 cubic feet of mortar. Yep. Okay. So 102.90 cubic feet of mortar. So for my brick, I have 102.90 cubic feet of mortar. Okay? All right, so again, two different ways to determine it. One per 1,000 square feet, or sorry, per 100 square feet for my block, and per 1,000 brick for my brick. And our chart tells us how many cubic feet of volume, tells us how many cubic feet of mortar we need to do each one of those, to lay up all of my block and to lay up all of my brick. Okay? All right, so now we're just going to go with that for our total mortar quantity, because all I have to do now is add these two together. Now, as a note, thinking back to our discussion on mortar, okay, is it possible that I would have to use those two numbers separately? Yes, it's very possible. In fact, it's likely. Okay, what did we say about our mortar? Thinking back to our mortar discussion, there are different types of mortar depending on whether my block is structural, okay, or not. My brick is never structural. I shouldn't say never, because there are rare situations of where it is structured. Just in modern construction, it's never structural. But if you did a retrofit on a building like I did for the Federal Reserve Bank down in St. Louis, Missouri, okay, $250 million project, that was such an old building that it was structural brick. Okay, so we had to use a type S mortar for that, any new brickwork that we did, because it was part of the structure. But in modern construction, again, we've talked about all of this, brick is rarely a structural component. Okay, so chances are I'm going to be able to use a type N for that brick, but I might very well be required to use a type S. I probably am required to use a type S mortar for my block. Okay, we're not going to go that far. Again, we're keeping it simple because this is your introduction to this. We're just going to say that we're using a type S for all of it. Okay, but again, I would want to understand that, and I would have to get into my specs to understand that. Am I required to use a type S for my block? Probably. Am I required to use a type S for my brick? Probably not. I can use a type N. And a type N is less expensive, so I would need to understand that. And I would need to understand that when I'm ordering it. I would need to understand that when I'm mixing it, on and on. Okay, so again, we see one more example of having to fully understand the resources, okay, the communication that's given to us. Okay, again, we're just going to say that we're going to use a type S for all of it for simplicity's sake. Okay, and the same thing is true for your assignment. Okay, so now we're just going to add those together. So 252 total cubic feet of mortar for both my block and my brick. Okay, so mortar total equals 252.90 cubic feet. Okay, all right. Again, understanding that if I were really doing a quantity takeoff, I would have to get into the specs and understand the different types of mortar that I'm required to lay. Okay, very common, very real world example. All right, so now finally we can say, all right, if I've got 252.90 cubic feet of mortar, how do I figure out numbers Numbers 13 and 14. I can see that number 13 is my sand and number 14 is my mortar, okay, or that should read masonry cement. That's a misnomer on my part, okay, but I can see that for my sand, I have cubic yards, and for my mortar, I have bags, okay, for my masonry cement, I have bags. Okay, again, remember, this is in its mixed state. That's not how we order it, okay? I'm not going to order pre-mixed mortar. Okay, again, it is possible. There are pre-mixed mortars out there. And if I were on a big enough job, that's what we would see. But for your purposes, we're saying that I'm going to order my sand separately and I'm going to order my masonry cement separately. Just as common. In fact, probably more common that it's done that way than if we order premix. We usually order premix if we're on big jobs and we have a high volume of this material. Okay? So for my sand, which is number 13, okay, I have 252.90 cubic feet of mortar. Whoops. Not done yet. Sorry. Going back to our chart, what did I almost forget? Right in between there, add 25% waste factor. I almost forgot to do that. Sorry. Okay, so this would be times 1.25. Okay, why 1.25? If I multiply it by 0.25, then I'm going to have to clear my calculator and add it to that number, which I could do, okay, but it's easier just to multiply it by 1.25, and then my calculator will give me the actual number that I want. Okay, so my 252.9 times 1.25 equals 252.9, 316.13 cubic feet. Okay, all right, so that's my total mortar quantity right there. Sorry, almost skipped a step. All right, so now for my number 13, right? Yep, my number 13, sand. I start with my 316.13 cubic feet of mortar. Okay, and what do I want? I want sand. Okay, again, I've already given it to you. Okay, I want sand. Okay, and I've given you the units. I see that my sand, way down there, number 13, okay, is in cubic yards. Okay, so we know, most of you know, our conversion factor. If I want it in cubic yards, I'm going to divide by 27 cubic yards per cubic foot, just like we saw with our concrete. Okay, concrete, we determine it in cubic feet because that's the information that's given to us. Same thing here. And then we divide it by 27 because we know that we order it, or our unit is, our final unit is cubic yards. So I'm going to order that by, or I'm going to determine that by taking my 316.13 and dividing it by 27. So I've got 11.7. I've got 11.7 cubic yards of sand. Again, we're not going to order 11.7. We're going to say 12, or I could go down to 11 and a half. Okay, but we will say that is 12 cubic yards of sand. Okay? All right. One question some of you might have at this point is you're saying, well, is that totally accurate that I'm dividing 27 into the total? Because I know that that's not the total makeup of that mixed mortar. Okay, a portion of it. We saw that it was a 3-to-1 ratio down in the lab. So 3 parts of it is sand, but 1 part of it is masonry cement. Okay, you'd be correct. Okay, but again, level of accuracy, does it matter? Okay, are we that concerned that we don't have a little bit too much sand? No, we're not. We've got a 25% waste factor here. Again, think back to what the trade experiences as they're performing this activity. Okay, if you think about block being laid or brick being laid, is there a significant amount of mortar that gets wasted? Yes. That's why we have such a high waste factor. And that's why we don't worry about getting that accurate to where we say, all right, well, I have to figure out now 3 parts to 1 part of my total so I can be totally accurate with my sand. There's no need for that. I could if I wanted to, okay, but again, my level of accuracy, I determine that. I say, no, there's no need for that. I've already got a very, very high percentage of waste, so this is close enough. It's a little more sand than I need probably, but that's fine when it comes to mortar because I know I waste a significant amount of that mortar. Okay, so that's close enough. We're going to have 12 cubic yards of sand. All right, so number 13, 12, we can put into our list. 12 cubic yards of sand. Okay. Oops, dang it. Now I just erased my information. I didn't want to. Sorry. So now I've got to go back and do my math real quick. That's what I get for doing it on the board. Okay, so okay, all right, so I hope that was the same. I did my math real quick there, but if not, you guys are following, it's fine. For my number 14, mortar or masonry cement, okay, I need to determine now how much mortar I need. Okay, so for my sand, I said, all right, I start with that 316.13 cubic feet of mortar. Okay, and I know that my final units have to be in bags. Okay, because again, we go back to our list and it tells us, that my unit is bags. Okay, what does that mean? What would I have to do to understand that? Well, what could I do? I could call a brickyard. I could Google it. Okay, what's the question that I'm asking? What is my conversion factor? How many cubic feet of material are there in a bag? Okay, that's what I would ask. So if I research that, and again, that's something that you're going to have to do on the job site on a regular basis. I'm setting up the math problem. I know that I order it by the bag. Well, okay, in order to determine how many bags I need, what I need to know is how many cubic feet do I have in each bag. Okay, again, I solved that problem. I call a brickyard and I ask that question. I drive to the brickyard and read the side of the bag if I want to. Okay, more than likely, I'm going to Google it and I'm going to find out how many cubic feet of mortar are in an average bag, how many cubic feet of masonry cement are in an average bag of masonry cement. Okay, I'm going to tell you there are 3 cubic feet per bag. Okay, all right. So, but again, that's a very good example of a simple problem that I would have to solve that most people don't have the experience in doing, but that's what we do in construction all the time. Okay, we're constantly solving those types of problems. We're setting the math problem up. Okay, you guys have heard me say it a million times, and my personal opinion, 99% of what's going on right now, okay, is an overreaction, and that's because most people don't have the ability to set the math problem up. But anyways, that is what it is. I'll save that for another day. Okay, but again, we set the math problem up and we solve for that information in order to solve for what we need to solve for. So if I've got 3 cubic feet of mortar for a bag of masonry cement, I divide 3 into 316.3. So 0.13 divided by 3. So I come up with 105.4 bags. Okay, again, I could go either way. Okay, so we will say 105 bags of masonry cement. Okay, and then that would go on my list. Okay, I would have number 14 would be 105 bags of masonry cement. Okay, so again, understanding a couple of things. One, how to read my charts at the back. Okay, and quick review. Okay, the bottom chart is my brick. Okay, gives me the dimensions of my brick here, which correlates to the dimensions of the brick here. Okay, this down here is my block. I come over to here, and I understand that for my block, I have to determine how many chunks of 100 square feet I have, or how many square. That tells me that for every square, or every 100 square feet, I need to use 6.0 cubic feet of mortar to lay that 100 square feet. For my brick, I have to determine what size brick I've got. Again, we have an engineered brick. For our example, that's my second one. So I come over here, 3/8 joint tells me that I have 8.6 cubic feet of mortar to lay 1,000 brick. So I take that 1,000, or I take the number of brick total, I divide it by 1,000, okay? And that tells me that for every chunk of 1,000 brick, I need 8.6 cubic feet of mortar. So I determine my total cubic footage, add my 25% waste factor, then I divide by 27 to determine cubic yards of sand. I divide by 3 to determine bags of masonry cement. All right. Okay, so again, hopefully everybody understood that, and go through that problem again, do the math through this example one more time, and then go to your assignment and complete that math. All right. Thanks, everybody, and I'll see you next time.